Hello everyone, welcome to Talk on Civil Engineering. Let us design traffic signal based on IRC method. So here you have a given data required to design the traffic signal based on IRC. So it is a right angle intersection, which is turns are prohibited. So major street is having 12 meters. So major street is having 12 meters of 4 lanes and divided. And minor street is 6 meters having 2 lanes. Okay. So that means, so here this is a major road. So let us take this as road 1. Major road is as road 1, and this is my minor road, that will be road 2. Okay, so road 1 is of 4 lanes, and divide if we divide this, it will be 2 lanes on each direction. Okay, so here this is 2 lanes, here you have 2 lanes, and here you have 2 lanes. Okay, and minor road is of 2 lanes, so that means 1 lane in each direction. So this is 1 lane here, and in another direction you have another lane. So IRC method, the traffic signal will be completely approximate method. So approximately we are going to design the traffic signal, and after that, using Webster method, we are going to check whether the total cycle time we have designed is sufficient or not using Webster method. Okay, yeah. So for designing for this given data, firstly we need to find the traffics, the PCU values for separate lane, for each lane. Okay. So firstly for road 1. So for road 1 is of 4 lanes. Okay, that means 2 lanes on each direction. And here we are going to take the maximum traffic from both directions. So here for major road, you have 600, on one direction you have 900, and on other direction you have 743. So 900 is maximum, so we are going to take 900. Okay, so now maximum approaching traffic for each lane, per lane will be 900 divided by 2, because this 900 is on 2 lanes. So this 900 traffic is approaching using 2 lanes. So if you divide with 2, you'll get per 1 lane. Okay, so it will be 450 PCU per hour per lane, for 1 lane. Okay, so similarly for road 2, so road 2 is having 2 lanes. That means 1 lane on each direction. Okay, now maximum approaching traffic will be, it is 278 PCU per hour per lane, because here this minor road is of 2 lane itself. 2 lanes అంటే డివైడ్ చేస్తే ఈచ్ డైరెక్షన్ కి 1 లైన్ వస్తుంది. ఓకే, సో 278 అనేది ఒక డైరెక్షన్ లో, 180 PCU అనేది ఒక డైరెక్షన్ లో. సో 278 PCU అనేది ఓన్లీ 1 డైరెక్షన్ లో ఫ్లో అవుతుంది, దట్ ఈస్ 1 లైన్, ఒక 1 లైన్ కే ఫ్లో అవుతున్నాయి. ఓకే, సో 2 డైరెక్షన్స్ కి 2 lanes మనం డిస్ట్రిబ్యూట్ చేసాం, ఒక్కొక్క డైరెక్షన్ ఒక్కొక్క లైన్ అట్లా, రైట్. సో ఇట్ ఈస్ 278 PCU per hour per lane. Right, now for designing aspect as per IRC 37, so we are going to design in 2 stages or 2 steps. So for first step, step 1 is based on pedestrian crossing timing. So it is based on pedestrian crossing time. For suppose here pedestrians are crossing this minor road, so the traffic on major road can cross the signal, right? So that means here it will be green. సో ఎప్పుడైతే మైనర్ రోడ్ క్రాస్ అయ్యేటప్పుడు, పెడెస్ట్రియన్స్ క్రాస్ అయ్యేటప్పుడు మనము మేజర్ రోడ్ లో గ్రీన్ సింబల్ ఇవ్వచ్చు. సిమిలర్ గా మేజర్ రోడ్ క్రాస్ అయ్యేటప్పుడు, మేజర్ రోడ్ పెడెస్ట్రియన్స్ మేజర్ రోడ్ క్రాస్ అవుతున్నారంటే మైనర్ రోడ్ లో మనం గ్రీన్ ఇవ్వచ్చు, రైట్. సో దట్ ఈస్ ద బేసిక్ కాన్సెప్ట్. ఓకే, సో పెడెస్ట్రియన్ క్రాసింగ్ టైం. సో యాజ్ పర్ IRC 37, the walking speed of pedestrian is 1.2 meter per second. Okay, so for road 1 crossing time, so what is the time that will be taken for a pedestrian to cross road 1? So it will be 12, because the road 1 is having 12 meters width. So entire from here to here he should walk from here to here. So 12 meters divided by 1.2. 1.2 is the speed. So if you want to get time of crossing, so we need to divide the width with the distance with speed or the velocity. So 12 meters divided by the speed is 1.2 plus 7. 7 we have taking 7 is like the start at కొంచెం losses ఉంటాయి, time losses ఉంటాయి కదా. So ఆ time losses ని మనం 7 seconds time losses తీసుకుంటాం. Okay. So 12 divided by 1.2 plus 7. So you'll get a value around 17 seconds. Okay. So pedestrians main road 1 ని cross చేయడానికి ఎంత టైం తీసుకుంటున్నారు? 17 seconds తీసుకుంటున్నారు. That means this 17 seconds taken by the pedestrian to cross road 1 will be the green time for minor road. Okay. అంటే 17 seconds cross అవుతున్నారు అనుకోండి, 17 seconds road 2 వాళ్ళు మనం పంపించవచ్చు కదా, road 2 traffic ని మనం green time ఇవ్వచ్చు కదా. So same thing we are doing here. So this 17 seconds will be the minimum. This will be minimum green time for road 2. This will be the minimum green time for road 2 because road 1 is busy with pedestrians. Okay, so that will be 17 seconds. So let it be G2. So road 2 annam kada, dini G2 andam. So G2 will be 17 seconds. Okay, similarly for road 2 crossing time will be, so here the minor road, the road 2 is of width 6 meters. 6 meters divided by 1.2 plus 7 losses. So it will be 12 seconds. Okay. So this 12 seconds will be the green time for road 1. So ikkada cross avutunnaru kada, minor road cross avutunnaru. So minor road cross avutunne mana major road traffic allow cheyochu, endukante vallu ila cross avutunnaru, pedestrians ila move avutunnaru. So manam major road traffic ni allow cheyochu. So green time will be 12 seconds. So the minimum green time for road 1, that is G1, will be 12 seconds. Okay, so this is based on pedestrian crossing time. These are not the final values. This is based on pedestrian crossing time. We need to go for next step. Next step is based on, so step 2 is based on critical traffic flow. So based on critical traffic flow in the sense, so wherever the maximum traffic, in which lanes, in which direction you're having maximum traffic, there the green, obviously the green time should be more. అంతే కదా. సో ఇప్పుడు మేజర్ రోడ్ లో మీకు ట్రాఫిక్ 900 ఎక్కువ ఉంది ట్రాఫిక్ అంటే ఇక్కడ గ్రీన్ టైం ఎక్కువ ఉండాలి. మైనర్ రోడ్ లో మీకు ట్రాఫిక్ తక్కువ ఉందంటే గ్రీన్ టైం తక్కువ ఉండాలి, రైట్. సో అదే ప్రిన్సిపల్ మనం ఇక్కడ అప్లై చేస్తాం. ఓకే, సో ఫర్ సపోజ్ ఫర్ 450 ట్రాఫిక్, దట్ మీన్స్ ఫర్ మేజర్ రోడ్, let the green time will be G1. Okay, and for minor road, that is traffic is 278, let this be G2. Okay, అప్పుడు మనకు G1 ఎంత కావాలి? G1 will be 450 divided by 278 into G2. Okay, just cross multiply చేశాను. So G2 ఎంత? G2 is 17 seconds. Okay, so G1 equal to 450 divided by 278 into 17 seconds. So this will be the green time for major street. Okay, so let me write. So minimum green time for major street. So that means road 1 based on critical flow is equal to, so G1 is equal to 450 divided by 278 into 17. So it will be 27.5. That means 28 seconds. Okay, so now just compare G1 from both steps. In step 1 you got G1 has 12 seconds. In step 2 you got G1 has 28 seconds. So this is maximum. The value based on critical flow is maximum. So the G1 will be 28 seconds itself. Okay, so now G1, the final G1 value will be 28 seconds. Okay, and G2 will be 17 seconds because if you apply the similar procedure, the critical flow procedure for G2 also, it will be much lesser. Okay, let us see that also. So this is not required, but for our understanding we are doing this. So for G2 will be same procedure, 278 divided by 450 into G1. Here G1 should be 12 seconds. So here G1, G2 are the values which we got from pedestrian crossing. Okay, so 278 divided by 450 into 12 seconds. So how much value you will get? So you'll get a value around 7.4 seconds, which will be much lesser than what we have provided for the road 2, the minor road. So we have provided 12 seconds actually. Sorry, 17 seconds. Actually, we have provided 17 seconds. for G2. So it is much lesser than that value. So that's the reason. ఎట్లాగో మనం మాక్సిమం వాల్యూ తీసుకుంటాం. సో ఈ వాల్యూ మాక్సిమం అని మనకు తెలుసు కాబట్టి మనం ఇది చేయాల్సిన అవసరం లేదు, ఈ స్టెప్ చేయాల్సిన అవసరం లేదు, నాట్ రిక్వైర్డ్. Okay, so the G2 value will be 17 seconds itself. Okay, yeah, so we got G1 and G2 based on step 1 and step 2 values. Now let us the third step, that is we need to revise the green time based on the total cycle time, because in total cycle time the clearance amber times and intergreen times will be added. So based on that we have to revise this G1 and G2. So the revised green time for traffic signal. So for this we are going to add 2 seconds as clearance amber. You can add 2 to 3 seconds, so I'm adding 2 seconds here. So this is for road 1 and 2 for both. Okay, and add 2 seconds as intergreen period. This is also for road 1 and road 2. Okay, now total cycle time will be total cycle time required. So for road 1 2 seconds plus 28 seconds is a green time and 2 seconds is a intergreen period. Okay, so total will be 32 seconds. And for road 2 2 seconds is amber, 17 seconds is a green time and 2 seconds is the intergreen period. Total 21. So the total will be 53 seconds. So let it be 55 seconds round. Let us round it to 55 seconds. Okay, so that means the difference of 53 and 52, the extra time will be 53 minus 55. So it is 2 seconds. 2 seconds extra you are getting. So this 2 seconds we can add this 2 seconds to road 1 and road 2. Okay, so therefore the final green time will be, so G1 equal to 28 plus 1, it is 29 seconds, and G2 will be 17 plus 1, 18 seconds. Now total you'll get 55 seconds. Okay, so total cycle length, this is cycle time, that is it is 55 seconds. Okay, so with this our design is completed. Just road 1, road 2, amber, green and intergreen period, red, and the cycle time. Okay, we know for both cases the cycle time will be same, 55 seconds itself. Okay, and amber we have given 2 seconds for both road 1 and road 2, and intergreen period also 2 seconds for road 1 and road 2, and green for road 1 is 29 seconds and road 2 is 18. Okay, so here 29 plus 22 plus 2, 29, how much? It is 33. 29, 30, 31, 32, 30. 33 minus 55, it will be 22. And 18, 19, 20, 21, 22. So 22 minus 55, it will be 33 seconds. Okay, so this is what we have designed. Okay, so this is what we have designed through approximate method, that is IRC method. Now we have to check this, whether whatever the green time you have provided is sufficient or not, as well as the cycle time provided is sufficient or not. So for checking the green time, we will be using approximate method itself. Approximately we are going to check the green times, and the cycle time we are going to use Webster method for check for green time. So for green time checking, we need to remember one thing. So whatever the first vehicle standing, it will take 6 seconds to cross the signal, the first vehicle, and the following vehicles will take 2 seconds to cross the signal. Okay, remember sir, this is also based on IRC recommended values. Okay, so the first vehicle will take 6 seconds to cross the signal, and the following vehicles will take 2 seconds. Minimum green time should be, this is for safety reasons. So for safety, IRC provided is 16 seconds. So 16 seconds on both directions, on both major minor road and major road. So the minimum green time should be 16 seconds. That also we need to check. Okay, so for road 1, so number of vehicles. So firstly we need to know how many vehicles are standing in the queue, right? So the number of vehicles per hour per cycle time. Okay, so it will be 450 divided by 55. So 450 is, what is 450? 450 is the number of vehicles per lane. So in major road. So 450 is number of vehicles per lane. Okay. So 450 divided by 55, you'll get a value around 8.18. Okay. Now minimum green time required equal to the first vehicle, how much time it will take? It will take 6 seconds, right? Plus the following vehicles will take 2 seconds. So 2 into how many vehicles? 8.18. So from 8.18, already one vehicle is here. One vehicle is taking 6 seconds. We have given here. So one vehicle ikkadiki vachesindi. So any vehicles untayi? -1. So you need to -1. Oka vehicle తీసేయాలి ఎందుకంటే ఒక vehicle ఇక్కడ ఆల్రెడీ ఇచ్చేసాం. Okay. So it will be 20.36 seconds. And what is the green time we have provided for road 1? So it is 29 seconds. So which is less than 29 seconds, which is provided. So therefore it is okay. So road 1 ki provide chesina green time is okay. Okay. Similarly for road 2, so number of vehicles per hour per cycle is equal to 278 divided by 55. So it will be 5.05 vehicles. సో ఇక్కడ మీకు 5.5 అట్లా వెహికల్స్ ఉండవు కాబట్టి మీరు దీన్ని రౌండ్ అప్ కూడా చేయొచ్చు, బట్ పర్లేదు, మనం ఎలాగో సైకిల్ టైం క్యాలిక్యులేట్ చేస్తున్నాం కాబట్టి ఇట్స్ ఓకే. సో మినిమం గ్రీన్ టైం రిక్వైర్డ్ ఈజ్ ఈక్వల్ టు 1 into 6 ప్లస్ 2 into ఆల్రెడీ ఒకటి 5.05 నుంచి 1 వెహికల్ ఇక్కడికి వచ్చేసింది కదా, ఎన్ని ఉంటాయి? 4.05. సో టోటల్ ఎంత? యుల్ గెట్ వాల్యూ 14.1 సెకండ్. ఓకే. సో మనం ప్రొవైడ్ చేసింది ఎంత? ఇట్ ఈస్ లెస్ దెన్ 18 seconds. వీ హ్యావ్ ప్రొవైడెడ్ 18 seconds. అండ్ మినిమం ఎంత? 16 seconds ఉండాలి యాజ్ పర్ IRC. 16 seconds మినిమం గ్రీన్ టైం. సో గ్రీన్ టైం కంటే ఎక్కువనే ఉంది. సో దిస్ ఈస్ ఓకే. వాట్ ఎవర్ వీ హ్యావ్ డిజైన్డ్ ఈస్ ఓకే. సో రోడ్ టు గ్రీన్ టైం కూడా ఓకే అయిపోయింది. ఓకే, సాటిస్ఫైడ్. ఓకే. సో గ్రీన్ టైమ్స్ వాట్ ఎవర్ ద డిజైన్డ్ గ్రీన్ టైమ్స్ ఆర్ సాటిస్ఫైడ్ యాజ్ పర్ చెక్స్. అండ్ వీ నీడ్ టు చెక్ ఫర్ సైకిల్ లెంత్ ఆల్సో. సో సైకిల్ లెంత్ ఎంత వచ్చింది? 55. సో 55 సైకిల్ లెంత్ ఓకేనా కాదా అనేది చెక్ చేయాలి. సో చెక్ ఫర్ సైకిల్ టైం. సో దిస్ చెక్ ఫర్ సైకిల్ టైం విల్ బి బేస్డ్ ఆన్ వెబ్స్టర్ మెథడ్. ఓకే. సో వెబ్స్టర్ ఫార్ములా గుర్తుందా? వెబ్స్టర్ ఫార్ములా, వాట్ ఈస్ వెబ్స్టర్ ఫార్ములా? C0 ఈజ్ ఈక్వల్ టు 1.5 into L plus 5 డివైడెడ్ బై 1 minus capital Y. ఓకే. సో మనకి L వాల్యూ కావాలి, Y వాల్యూ కావాలి. సో Y వాల్యూ కావాలంటే వీ నీడ్ స్మాల్ a, that is flow, traffic, actual traffic flow and saturation flow. Okay. So firstly let us calculate what is capital L, that is lost time per cycle. Capital L, that is lost time per cycle. So this will be the total, the amber time plus intergreen time plus the time lost for delays. So vehicle start కావడానికి కొద్దిగా delay time తీసుకుంటది కదా, that time also we need to include into 2. Into 2 is for you have 2 roads. So that's the reason we are multiplying with 2. Okay. సో ఆంబర్ ప్రైమ్ ఎంత తీసుకున్నాం మనం? 2 seconds తీసుకున్నాం. ఇంటర్ గ్రీన్ టైం ఎంత? 2 seconds. రెండు రోడ్లకి 2 seconds ఇచ్చేసాం. ఒకవేళ రెండు రోడ్లకి డిఫరెంట్ వాల్యూస్ ఇస్తే అప్పుడు మీరు ఇంటూ 2 కాకుండా మనం ప్లేస్ చేయాలి. ఓకేనా? ప్లస్ టైం లాస్ట్ 4 seconds గా తీసుకుందాం. అప్రాక్సిమేట్ గా 3 to 4 seconds ఉంటుంది. సో 4 seconds తీసుకుంటున్నాం. ఇంటూ 2, ఎందుకంటే 2 roads కి సేమ్ వాల్యూస్ ఇచ్చాం కాబట్టి ఇంటూ 2. సో ఇదంతా అవుతుంది 16 seconds. ఓకే. సో L ఈజ్ ఈక్వల్ టు 16 seconds. ఓకే. అండ్ వాట్ ఎల్స్ యూ నీడ్ టు ఫైండ్? Y వాల్యూ వి నో. Y1 రోడ్ 1 కి ఎంత? సో ఫస్ట్ సాచురేషన్ వాల్యూస్ కనుక్కుందాం, అప్పుడు మీకు y వాల్యూస్ క్లియర్ గా తెలుసు, ఐడియా వస్తుంది. IRC is provided a formula to find out the saturation value, that is 525 into W. W is the width of road. Okay. So this equation, this formula is applicable for a width of greater than or the width of ranging between 5.5 meters to 18 meters. So 5.5 నుంచి 18 meters వరకు మనం ఈ ఫార్ములా యూజ్ చేయొచ్చు సాచురేషన్ ఫ్లో కనుక్కోవడానికి. For less than 5.5 meters, IRC provided values for different width of roads. So you need to memorize these values as well. So here it is width and this is saturation flow. So for 3 meters, 3.5, 4, 4.5, 5 and 5.5 meters. So for 3 meters, the value is 1850. For 3.5, it is 1890. 1950, 2250, 2350. Sorry, it is 2550, and it is 2990. Okay. So for based on width, you need to take the values, right? So for road 1, that is S1, road 1. So S1 will be 525 into W. So what is the W for road 1? Total width is 12 meters, but we need to take only on one direction, right? So one direction, 2 lanes ఉంటాయి. 2 lanes ఎంత 6 meters. అంతే కదా, 12 divided by 2 చేస్తాం అనుకోండి. టూ డైరెక్షన్స్ ఉన్నాయి కాబట్టి 12 divided by 2 చేస్తే you'll get 6 meters. Okay, so width is 6 meters. So 6 meters అంటే మనం డైరెక్ట్ ఈ ఫార్ములా యూజ్ చేయొచ్చు. ఓకే, సో 525 into 6. సో వాల్యూ ఎంత వస్తుంది? 3150 PCU per hour. Okay, similarly for road 2, S2 will be, so width ఎంత ఇక్కడ? Width, firstly we need to know the width, right? So width for road 2 will be, so total 6 meters, so 6 divided by 2 చేస్తే 3 meters వస్తుంది. So 3 meters అంటే for this formula is not valid, so because this formula is valid greater than 5.5 meters. సో 3 meters అంటే టేబుల్ నుంచి తీసుకోవాలి. సో 3 meters కి సాచురేషన్ ఫ్లో ఎంత? S2 will be 1850 PCU per hour. Okay, so saturation flow values వచ్చాయి. So now we need Y1 and Y2. So Y1 అంటే the critical flow in road 1. So road 1 ఎంత తీసుకోవాలి? ట్రాఫిక్ మనము 900 తీసుకోవాలా, 450 తీసుకోవాలా? How much value we need to take? So here we need to take 900 because saturation flow కి width ఎంత తీసుకున్నాం? 6 meters అంటే టోటల్ width తీసుకున్నాం కదా, 2 lanes width తీసుకున్నాం కదా. 6 meters అంటే 2 lanes width కదా, అంటే 2 lanes లో ఎంత ట్రాఫిక్ ఉంది? 900 ఉంది. సో 900 we need to take. So Y1 will be 900 PCUs per hour and Y2 will be 278 PCU per hour. Okay, so road 2 లో ఓన్లీ ఒకటే లేన్ ఉంది, that is 3 meters. So direct 278 తీసుకున్నాం. Okay, so now just let us apply this in the C0 formula. So C0 is equal to 1.5 into L ఎంత? 16 seconds plus 5 divided by 1 minus. So capital, what is capital Y? Capital Y is equal to Y1 plus S1 plus Y2 plus S2, right? So capital Y is equal to Y1. What is Y1? Y1 is 900 divided by S1 is 3150 plus Y2 is 278, S2 is 1850. Okay, so if you calculate this, you'll get a value around 51.42 seconds, which is less than what we have provided. We have provided 55 seconds. Okay, so therefore the IRC design, what we have designed, the signal design is okay. So it is satisfied. Okay, so 55 seconds what we have provided is greater than the required value. So this is the required value. Okay, so therefore it is satisfied. So this is how we are going to design the traffic signal based on IRC 37. Okay, thank you all.